This grainy image shows an asteroid called Bennu, and it may be on a collision course with Earth.
Odds of Bennu hitting the Earth are less than 1 in 2,000. That's still considered high for this class of object. Typical odds would hopefully be lower than 1 in a million.
Bennu is smaller than the asteroid that killed the dinosaurs, but it could cause a tremendous amount of damage in the local area where it hits. For instance, it could really damage something the size of a large city, or if it hit just offshore, it could create a tidal wave.
In September 2016, Bashar and Peter will send a probe to photograph Bennu in detail and reveal its secrets. But a mission like this is fraught with potential pitfalls. In August 2014, a spacecraft called Rosetta arrived at another small body, a comet caught in Jupiter's gravity. 3 months later, the Rosetta team attempted to land a probe called Philae on the comet's surface, and it ended in disaster.
Philae was equipped with a couple of harpoons, so that when it made its landing, they would shoot out and ideally try to lure it there. Except that apparently the harpoons did not fire when Philae landed. So because of that, Philae hit the surface and bounced. And it bounced several times because of the comet's rotation and the lander's own velocity. And it wound up coming down in an area of the comet that we didn't have good maps for. And so basically the lander was lost.
The team is determined to see their mission succeed. That's because there is more to learn from Bennu than whether or not it will collide with Earth. It could unlock the origins of life on our planet.
The Earth formed when objects slammed together. But later on, as it cooled and water became a large part of the surface composition, then it was possible for future impacts with smaller objects to actually bring in organic materials that could survive on the surface. That's how many people think organics came to the Earth, is through those impacts from asteroids. When we get a sample of Bennu back into our laboratories, we're going to be looking at material that formed in the initial phases of the formation of the solar system.
If we could someday prove that the building blocks of life on Earth actually came from space and not from our own planet, it would turn everything we understood about the origin of life on its head.
Osiris Rex will not attempt a landing like Philae. Instead, it will get a sample of the asteroid with a revolutionary new system called TAG-SAM.
TAG stands for touch and go, and SAM is sample acquisition maneuver. So TAG-SAM is the actual act of reaching out, touching the surface of the asteroid and gathering the sample and pulling away.
Once samples from Bennu arrive back on Earth, we can test them for the kinds of organic materials that could have seeded Earth 4 billion years ago. But to successfully retrieve the sample, the cameras must function perfectly.
The cameras are one of the critical experiments on this mission because as we get closer, it can refocus and actually becomes more like a microscope. And it can detect grains that are just a few millimeters across. So when we get to our sample site, we want to get the highest resolution possible.
With only months to go until liftoff, the clock is ticking to get Osiris Rex right.
We'll be launching in September of 2016. So we have a schedule pressure here that I think does take its toll on the team. There are a number of things that we're trying out for the first time, and that keeps people up at night at NASA.